we'll do this one in Desmos, so pull out your Chromebooks, play along. I think we can get some good practice on a couple things. And honestly, I mean, you know me, I love Desmos, but you know, the ones we did yesterday, I think the calculator was more than enough to get the correct answers for. The last example was similar to this one where you had two things working against each other. We usually call that a rate in, rate out problem. But those are usually based on time. So we did have money coming in at a rate and we did have money being spent at a rate. So that does fit the mold of rate in, rate out. But this one really solidifies what you'll see more often. So like I said, I had to kind of go on a hunt to find one that didn't use time as the independent variable. And I found one, so it was a good one to do. But my guess would be, if I had to bet, I would say it'd probably time-based that you'll see on the AP test. But, you know, sometimes when you bet, you lose. So it's good to take a look at everything. Alrighty, so again, we saw this one. The Mighty Cable one was a swap out. We had something different there in B11, but this was there in B11 when we did this the first time around. There's no snow on Janet's driveway when snow begins to fall at midnight. From midnight to 9 a.m., which is nice because T is going to equal the actual hour of the day because it started at midnight. We have the rate at which snow accumulates on the driveway. So our function is a rate, no surprise, because we can integrate a rate and figure out how much change actually happened. And we can also take the derivative of it to figure out how that rate is changing. We'll see what they ask us. Cubic feet per hour.
Good morning, teachers and students. Please pardon this interruption. Teachers, if you can please look around the room and check for dress code at this time. If you have not done that already, please send to the auditorium any students who are out of dress code. This includes hoodies, sweatpants, slides, anything that's not dress code compliant. Thank you.
Yeah. All right. So now that I've sent everybody out of dress code down, since it's recorded, we'll say it happened, and then it did. We will keep going with the problem. Janet starts removing snow at 6 a.m. That is built into what's going on here. We have a rate for that too. I do miss pointing at the board, if you haven't noticed, because I find myself going over there more and more often. We do have that rate as well. That rate does kind of match what's going on in the problem because the rate at which she's removing snow is 0 between hours 0 and 6. And then she, for an hour, manages to remove that snow at a constant rate of 125 cubic feet per hour. No variance whatsoever in that time period. She is what she is, very diligent at being sure that that snow is constant rate. But for whatever reason, for the last 2 hours, she slows down. So a little bit of a weird problem. Doesn't necessarily always make sense in the real world. But that's what's going on. Constant rate for an hour, lower constant rate for the next 2 hours. Letter A says to find f prime of 5 and using correct units, explain the meaning of the value in the context of the problem. So it says the thing that we always do. Know your function. Don't look at G, look at F. We need to do f prime of 5. Here's going to be my suggestion since I'm going to do this in Desmos. When you know you're going to have to use a function several times, let's start by putting F and G into Desmos. So we'll do F first, and then we'll do G. I'm going to jump back and see if I have an E-9 on the desk so I don't have to keep guessing at what the function is. I know I have a copy somewhere. Is it up here still? It'll show up right when I stop looking for it. Pain in the neck. All right. E8, E6, E something else, E4, D8, E9, there she is. All right, cool. All right. So F, I'm going to use X. I think I just always get annoyed at myself when I use T. So I'll use X there. Equals. 7x e to the cosine of x. 7x alpha e to the cosine. Oop, I didn't do to the. Cosine of x back outside dx. I'll say what I said yesterday again. I don't need dx, so I'm not integrating yet. There we go. There's my function. I'll say what I said yesterday again. If this is calculator active, do not try to integrate this. This thing does not have an antiderivative that you can easily find, or probably, I just don't know. I doubt you can find an antiderivative for this. You would need something that when you took the derivative, you still had e to the cosine x, but think about taking the derivative of something that has an e to the cosine x in it. The chain rule would give you a sine x out front, a negative sine x out front, but that's not there. So, functions in general don't have what we call a closed form antiderivative, something that you can just write out simply. The other way around with derivatives, there was just a rule to follow no matter what. So this thing most likely does not have an antiderivative. If you do something like write 7x e to the sine x, that's wrong. 7x squared over 2 e to the sine x, that is also wrong. Whatever you try to do to this thing is going to be wrong. It's not meant to be antiderivative. That's a word. It's meant to be, plugged into your calculator and see what you get. So we've got to find f prime of 5. So I am literally going to take the free point and type in f prime of 5, which is much easier not on this iPad, but there we go. Boom. All right. And we know what we're doing, so we are going to write f prime of 5 equals 53.866. Rounded or truncated gives you the same. 53.866. That is algebra 1, and we want calculus. What number did I say? Thank you. Okay. So using correct units, explain the meaning of the value in the context of the problem. This is not something that you're making up. You start off with what they told you F was. So F is the rate at which snow is accumulating on Janet's driveway. So the rate at which snow is accumulating on the driveway. I'll say the driveway. Is either increasing or decreasing. It is increasing at a rate of, that's standard, at a rate of 53.866. It's the rate at which a rate is changing, so it's going to have two pers in its units. So we're going to take your, what is it? Cubic feet per hour. And we need to say that this is instantaneous, and the way we do that is we say at time t equals 5 hours. Boom. A good percentage of the tests that are taken have this exact sentence on it. I mean, maybe Janet's driveway, little tiny things. But when a grader sees that written out that way, they, you can just look at it and say, that's right. Questions on that? On which intervals is the rate of the snow accumulating increasing? Sign chart. Yep. Actually, not sign chart as much as looking at the graph, because we can't make a sign chart from what we were giving. So we want to know whether the rate of the snow is increasing. So we are looking for F to increase, correct? The rate of the snow is F. So we want to know when F is increasing, so we have to look at the first derivative. So we're going to change in Desmos from F prime of 5 to F prime of X. I hate that this brings up that keyboard that doesn't work every time I switch over to it. We need to clean this up. We need to do two things. The whole problem is between times 0 and 9 or 7. I forget. 9, right? I don't know why I closed my packet. Yep. So the whole thing is from time 0 to 9. So I'm just going to go ahead and I have the nice touch screen, but you can go in here and make this go from -1 to 10 on your x-axis. That makes sense. And then I can scroll up and down, shut off purple so I don't confuse myself. It looks like, boom, I'll go up to 70. So I'll go from -1 to 75. Why not? Not an exact science, but you do have to actually type the numbers in if you want it to work. So my y-axis should now be good. Yep. And I can even just take one zoom out. So I feel like I set it up and then I take one zoom out and I should be in good shape here. So we want to know when the rate of the snow is increasing. So we want to know when the first derivative is positive. So it sure looks like we're going to say from time 0 to 1.114. That's the right page. I'm going to write these down as I'm doing. And then it is increasing from 6 to 6.439 to 9. If this has a dead stop at 9, I'm going to stop at 9. Okay. Alrighty. So I've got those numbers written down. I'm going to go back to Algebra 1, apparently. There we go. All right. Increasing, decreasing intervals, we used close parentheses, so 0 to 1.114 and 6.439 to 9. That question does not say to justify, so the scoring guide. Let me take a peek at the. From 6.43912 to 9? It's when the derivative is positive. So this is f prime. So f. The question asks, when is the rate of snow increasing? The rate of snow is f. This graph is of the derivative of f. Anywhere you read a derivative and you get a positive value, the function is increasing. So 0 to is this, which is 1.114. Oh, is this me? This is me reading Desmos wrong, isn't it? Yes. So where is this dot at? That's this dot. That's this dot. Oh my gosh. Yeah. Yikes. So it is. So it should be this dot here. I've clicked on the wrong dots. Absolutely. Thank you. Yikes. I mean, it does make them black for me. So it does. Yep. Yeah. It does make them black for me. So I just need to be, I and you just need to be more careful when we do that. I mean, maybe you don't because you did not get that mistake. Okay. So yeah, so let's fix that. So it's 2.772 to the number that I had before. Thank you. Cool. All right. You could get those numbers off of F as well, because it does give you relative mins and maxes. So I could have looked at the function itself and looked for where it hits that relative max, I should say. So 0 to 1.114. I could look here and say it goes from 2.772, same number, to 6.43912. So you can actually look at to see where the function is increasing. You could also look at f prime. The reason I think I go to f prime is if they say justify, you need to use f prime to justify. Something like that? So yeah, so you do need to use f prime to justify, but both of those will get you the answers. Hi. Yes.
Inline snow is $60, and if throughout the whole school, if you make up $5,000, you can have a student. Thank you.
Thank you. Thank you. Yep. Yeah, I feel like the announcements are always like that, like when they come in Panther period as well. It's just like the meekest human beings in the world saying things. Yeah. Okay. Okay, so updated and correct answer because I know how to read Desmos. It's probably based on how many students are in here. We have 12, so it's probably $5 a student. Yeah. Yeah. We can do that. Yeah. So yeah. We'll find out more information. All right. I mean, Jaden will just work a couple hours and pay for all of us. That's usually what he does anyway, right? Yeah. All righty. Okay. Letter C. What is the rate of change of the volume of the snow at 8 a.m.? Watch these rate in, rate out problems. A and B, we're just talking about the accumulating snow. Now letter C is introducing a new function, how much snow is actually there. So at 8 a.m., there is both snow coming on the ground, and at 8 a.m., there's also this person removing snow from the ground. So this is the one in B11 where we defined a new function. So we have to define the volume of the snow on the ground. The way we can do that is we'll call that V of t is the volume of snow on the ground. Which is not a rate, right? So we have to then figure out what V prime of t is. But in a rate in, rate out problem, it's just the rate in minus the rate out. So V prime of t is F of t minus G of t. The rate at which that volume of the snow on the ground is changing is the rate at which it's coming in minus the rate at which it's going out. It's usually set up this way. It should be pretty obvious that these are positive values, so you have to subtract it. This is representing the absolute value of the decrease in the snow. So when we discuss it that way, that's usually how it happens. So this isn't even any calculus because we just need to find the F of 8 minus the G of 8. And that tells us what V prime of t is. So the G of 8, you just read the thing, right? It's just a piecewise function that is constants. Which constant is it? And we go back over to Desmos and we type in F of 8. Make sure we don't do F prime of 8 this time. That's why know your function is so important. F of 8. So it's going to be 48.417. So for my work, I'll put that one in. It would be interesting to figure out how much, like 108, just off the side, like how much is that? I mean, it's 108 cubic feet of snow in an hour, though. And it had been snowing 6 hours before she went out. I don't know. Anyway, real world part of it doesn't matter. If you want the real world, take some other class. And then we should have our answer here. I'm just going to jump back to Desmos and type in minus 108 on my line. I hate that keyboard. Minus 108. Boom. And there's my answer, negative 59.583. Try to do all my work in Desmos. That way I never have to worry about rounding errors. Negative 59.583. Negative 59.583. And the rate on that is correct. It's because it's F minus G. That means that both of those must have the same. If you're going to do adding and subtracting, you have to add and subtract same labels. So it's got to be cubic feet per hour. All right. And then finally, letter D, at what time is the volume of the snow on the driveway at a maximum? So what we need to do is we actually need a T value when V of T is at its maximum. So the way that we're going to, and actually it's kind of nice. We don't actually have to figure out how much snow is there, but we'll talk about that kind of as we go along. Because we're kind of in that situation where I ask, which problem are we? Are we problem one or are we problem two? But we're in like that special case where problem one and problem two are the same thing, because at time zero, there was zero snow. So if I was actually doing a problem two problem, I would be doing 0 plus. So I'm essentially doing the same thing as over here. So that means we need to find the critical values of V. We need to find when V prime of T is equal to 0. So now we've got to get V prime. We actually need to get V prime into Desmos. So now I've got to put in a piecewise function, G of T. Down. And we do a piecewise function. It may have been a minute since we've done one, but we define it. G of X equals, so definitely do this one for the practice. G of X equals, and we use the curly brackets, which are on your keyboard. You have to press shift to get them, but they are there. I don't have to press shift. All right. And it's basically going to be interval colon function. And in this case, our functions are just constants. So G of T is 0 from 0 is less than or equal to T to 6. So I'm going to type in the inequality first, 0 less than or equal to X less than 6. Then I'm going to hit my colon and 0. I see some fingers furiously typing away. And then it's a comma. And you just one after the other. So 6 less than T less than or equal to 7. 6 less than X less than or equal to 7, colon. And that's going to be 108. Boom. Thank you. 125. And then last but not least, comma, from 7 to 9. 7. I must have a typo there. One of those less than or equals is not supposed to be there. Desmos actually won't give you a hard time if you don't get the less than or equals right. So it doesn't matter. But yeah, that problem has less than or equal to on both 7s, which it shouldn't. Anyway, 7 less than X less than 9. I shouldn't say that it won't give you a problem, but finding an interval, it won't won't give you a problem. And then we're going to get a colon. And we want 108. All right. So now we will bring that down, close ourselves up here. And now what we want the 0 values of f of x minus g of x. So I can actually type f of x minus g of x in and get a picture of that graph. Mm-hmm. And I think we're in a little bit of a different situation here, because usually we're looking for 0 values, right? When the derivative is 0, that's a critical value. But here, our derivative is undefined. When there's a jump in your graph, the derivative has to be undefined. So the critical values are going to be the values where these numbers stop. So we might actually run into a problem with our less than or equal to here. So I'm just going to go back and make sure that I've got them at least in a way that makes sense, because it's basically one side has to be less than or equal to in order for you to get an x value here. So I've got 0 less than x less than 6. I've got nothing at 6. So let's make one of these less than or equal to. I think this was how the problem was supposed to be laid out. And then this should have been 7. Usually it matches the first one. So 7 less than or equal to. Boom. Okay. So there we go. So basically all I did there was I shifted in that middle. I think I have the less than or equal to on the wrong spot. I think it's supposed to be on the 6, not the 7 in the middle. And then the endpoints, yeah, the endpoints will always be less than or equal to, and then they'll be consistent about picking the middles. So if they go like in this one, in their first round, they said, okay, so 6 doesn't apply to the top, it'll apply to the bottom. 7 doesn't apply to the top, that's my mistake, it applies to the bottom, but the endpoints will always be there, especially if it's an EVT question. So we have a situation where, sometimes we say we only have one critical value, we have 2 critical values, but at that second critical value, it doesn't change from increasing or to decreasing. So we'll make our function say something like that. So hopefully we can find these. So let me click on it. Oh, it's right. We don't need to find them because it's 6, right? Duh. I'm like not thinking through this, right? That jump is at 6 because that's where the pieces jump. That jump is at, right. Then the next jump, which we don't really care about because it's decreasing and it stays decreasing. She just slowed down her shoveling. So that's what's going on there. Yeah. So yeah, that is t equals 6 because otherwise it would be hard to find that value because there's nothing to really set it equal to. But why would it jump? Because it's a piecewise function. Yeah. So, we can't say we only have one critical value. That would be a mistake, but we'll say t equals 6 is a critical value, and the function changes from increasing to decreasing and remains decreasing the rest of the time. So the answer is t equals 6. Go back to that. So I'm going to actually get rid of this and say v prime of t is undefined. Usually our connection is equal 0, but in this case where v prime of t is undefined, let's say t equals 6 and t equals 7. Make our sign chart. 6, positive, 7, negative, negative. And we'll say t equals 6 because the function only increases before 6 and only decreases after 6. And I'm not going to say the function, I'm going to say v of t. So kind of editing as I go along here. Only increases before 6 and only decreases after. So again, another EVT problem where I was saved from having to make the table. If you have only one critical value, or you have a situation like this one where although there were 2 critical values, the second one was a dud. Nothing happened at 7 that was important to what we were answering. Otherwise, if you were going to have to do this as an EVT problem, you would have to figure out what v of t is. So v of t, this is not what you have to do, but I just want to talk about it in case you end up in a situation where you have to do this. V of t would be 0 plus the integral from 0 to t, and we're going to have to change variables here to x's, of f prime of x minus g prime of x dx. So this would be the alternative way to do it with the EVT. That should make sense. Basically what I'm doing is I'm taking what I defined v of t as up here, or v prime of t as up here, and I am integrating it. But integrating it alone tells us how much change there is. It doesn't tell us the actual total volume of the snow. So that's why I put the 0 plus. In this situation, do I have to put the 0 plus? No, I'm still correct. In another situation, if they said there were, 70 cubic feet of snow on the ground when it started to snow or something like that, then I would absolutely have to have that 70 plus there. So that's what's going on in that one. But that can just go into Desmos. You can put 6 and 7 in to make your chart. So I do want to show you that. TV of t. It does take a minute to remember what your t, v of t, and I would have to have 0, 6, 7, and 9 here. So when I moved over to Desmos, remember I have f prime. Actually, should I have written f prime there? No, I realized that. Thank you. Yep. That was a good example of me thinking, well, f is a rate, so it's a derivative, but it is defined as f in this problem, not f prime. So yeah, it would literally just be doing, 0 to 0. Well, we know that one, 0. However you want to do it, I can just say, I might do it just this way, int 0, because all I have to do is just change this number 3 times. 0 to 6, f of x minus g of x. I don't know what happened there. And then a dx should work. Hopefully I don't, nope, it wants parentheses. If you're ever doing an integral and it's not happy, chances are it just wants parentheses. There we go. So again, we'd have 142,274, which should be the biggest value we get. Otherwise, I don't know what I'm doing. And then jump back and put 7 and 9 in. Yep. So change the 6 to a 7. Definitely easier to do on a laptop. There we go. 7. Good. 133,313. And last but not least, the 9 should be even lower than that. Keep pressing the wrong button. Go away. Bad keyboard. 26.334. So same conclusion, justification works equally the same in both ways. I know which one was easier, but you don't always get that. This is the, one critical value. It's the critical value I needed. If I want an absolute max, I need to go from plus to minus. If they said absolute minimum, I mean, that would be weird to ask in this question, but this sign chart wouldn't help me with absolute minimum because it could either be the front end point or the end point. We just don't know. Obviously, if it started out at 0 and it's snow on the ground, it would have to be the front end point because you can't have negative snow. Last time I checked. And we've lived here for a while, so we've never seen negative snow. All right, questions on that one? All right. From here on out, it is for you to learn how to do this on your own, right? Like, there's really no more I can do other than help you, but no more. Me doing more out loud in front of you isn't going to help anymore. So, like I said, let's hit stop on that.